Okay, so trig functions. Basically, they are a ratio of the different sides of a triangle. So typically you've got, like, based off of one angle, which is called your reference angle. So we're going to make this one down here our reference angle. And in trig class, we like to use Greek letters to represent angles. So we're going to say that is the Greek letter theta. Right? It's not a 0 with a line through it. It's not the circle thingy. It is a theta. You just need to know how to say it.
How do you get a theta with my body?
All right. So, the first one we're going to talk about is sine. So, sine of theta is going to be...
Would it be S-I-G-N?
No. Technically, it's S-I-N-E, but we abbreviate it to S-I-N. So, it's not sin, it's sine in math class. Math class is not going to make you sin.
You're responsible for your own actions, Zach.
Okay. So it's going to be the opposite side. So the side across from it. So that's your opposite side. Right? The one that touches the angle is the adjacent side. And then the one over here is still your hypotenuse. I'm going to move this down a little bit so it's like... All right, so sine is always going to be opposite over adjacent. No, over hypotenuse. Sorry. Yes, SOHCAHTOA. We'll get to that in a second.
I don't understand what any of this is. I'm just copying it down.
Well, we're going to, I'll do an example with some numbers here in a minute.
I feel like I just had dreams about this stuff. And the next day I know it.
What?
Okay.
You built
All right, and we've done this before. We did a little bit of it in geometry. We did a little bit of it. I crammed in a lesson in the Algebra 2, but normally we would have spent a whole chapter going over this in Algebra 2. So, all right, so then cosine of that angle is going to be the adjacent side over the hypotenuse. Right, so adjacent side is always the side that's touching the angle. And the hypotenuse, again, is always the one that's across from the right angle. Always. All right, and then our last one is tangent. And tangent is opposite over adjacent. All right, so to help remember these, yes, we say SOHCAHTOA, like Zach was trying to scream a minute ago. Right, so it's sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. SOHCAHTOA.
Don't you...
So sine over hypotenuse.
No, sine is opposite over hypotenuse.
So, let's say in this example of this triangle, you're taking the sine of theta, and let's say that with the values given you get 6. Wouldn't the opposite side be 12? Is that how that works? Isn't it something like that?
Kind of, sort of. You didn't quite get enough information there, but...
Okay, so sine opposite hypotenuse, cosine adjacent to hypotenuse, tangent is opposite of adjacent.
Yes. The sine of angle A, right, the cosine of angle A, tangent of A, and then we're also going to do it from angle B. All right, so before we do this, what are we missing? Right, we're missing side C. How do we find side C?
Pythagorean Theorem.
Pythagorean Theorem.
This is torture.
If you think the Pythagorean Theorem is torture, you are in for a really long year.
Oh, I guess I better buckle up.
That's right. Also, is your 5-minute ban up yet? So you've got a squared plus b squared equals c squared, right? So a is 5, b is 12, 25, 144, it's 169, c squared, so c is 13.
So in the case of A and B always being 5 and 12, it's always going to be 13.
Mm-hmm.
So I can memorize that.
Mm-hmm. They're Pythagorean triples. You ever heard of those before?
Yeah.
So you've got 3, 4, 5, 5, 12, 13. Those are the most common ones, and then any multiples of those. So like 10, 24, 26 would be one because you multiply everything in this by 2. 6, 8, 10. So they're fairly straightforward. All right, so sine of angle A. So in that case, angle A is going to be our reference angle. So we're going to look from A. So from that, which side is going to be our opposite for this one?
A.
Right, yeah, so this is going to be our opposite. B is going to be what? Adjacent. And C is always going to be the hypotenuse. So that's going to work for when we're finding sine, cosine, and tangent for angle A. All right, so sine of A, sine is what? How do we find sine?
Opposite over hypotenuse.
Opposite over hypotenuse. So it's equal to 5 over 13. Bam, done.
There's no sign.
We're not even, we don't need those today. There's a, where is it? There's
Well,
a,
some calculators have.
they do. There's a trig button on it. You have to like,
We're just leaving it at that.
yeah, that's all you do today. We're not even using the calculators yet.
Let's see this morning.
We will. Give it another week.
Wait. Oh, it's above the pi button.
Yeah. You hit second pi and then that gives you your
Oh, and you got
functions.
minutes.
We do a whole section on using it. You get the hang of it. I didn't realize that when I ordered these calculators, or else I would have picked different ones. So sorry.
It's coming over on you.
All right, I'll take it. Okay, so cosine of A is what? How do we find cosine?
4 over 13.
All right, so it's adjacent over hypotenuse, which is 12 over 13. And then tangent is opposite over adjacent, so that is going to be 5 over 12. Done with angle A. All right, so then for angle B, all right, so let's get rid of that. Right, hypotenuse is always going to stay in the same place. For angle B, though, it's going to be up here. So which side's going to be our opposite this time?
Opposite of B.
Yeah, so this is going to be our opposite. This is going to be our adjacent. So your opposite and adjacent are going to depend on what angle you're looking from. Right, so this is opposite of angle B. This is adjacent to that. So hypotenuse is always going to stay where it is, though. Your opposite and adjacent are going to switch. So the sine of angle B would be what? 12 over 13. Cosine of B. And tangent of B. 12/5.
Oh, this,
Yeah, opposite over adjacent. All right. Any questions? We are like right on time. The bell's getting ready to ring. All right. Your homework is page 6, 1 through 3.
You can't find the sine and cosine of C, can you? Because the
Right.